Alright, here goes page 5 of the review. Looks like we need to write these complex numbers in a standard form, which means that we should be seeing a plus bi in the end. Probably one of the main things we need to remember is that I squared equals -1, because I is equal to the square root of -1. And the last thing is that if we have an imaginary number in the denominator, we need to get rid of it. So, remove it. So, let's see, it looks like we have an addition problem here. So make sure to look at that. This is not a multiplication problem. So basically just combine two like terms. So I have the real numbers, which are 3 and 5, so that would give me 8. And then 7i plus -4i would be just positive 3i. So there that is in standard form. Looks like the next one's a subtraction problem, so probably the best thing to do would be to distribute that minus sign through there. So it's going to be 3 plus 7i, so minus 5, and plus 4i. And then go through those combining like terms. And so 3 and then -5, that would be -2. And then 7 and 4 i's would give me positive 11 i's. Alright, this is a multiplication problem. So I'm going to use distribution. So 3 times 5 is 15. 3 times -4 is -12i. 7i times 5, positive 35 i's. And then 7 times -4 is -28i squared. But since I squared is equal to -1, it would be -28 times -1, which would be positive 28. So now I have these two real numbers here, which 15 plus 28 is 43. And -12 i's plus 35 i's is 23 i's. Alright, let's see. Here we have a division problem, so everything that we don't want an I in the denominator. So in order to get rid of that I in the denominator, we have to multiply by the denominator's conjugate, which is 5 plus 4i. So you gotta make sure you switch that sign. Whatever you do to the bottom, you gotta do to the top. And the whole point of this is just to get the I out of the denominator. So up top we have 3 times 5, and 3 times 4i, and 7 times 5, 7i, 35i, and 7i times 4i is positive 28i squared. And all of that is over 25 plus 20i minus 20i. So here we see why it's so important to change those signs. And then minus 16i squared. So of course the positive 20i becomes a negative 28, and the negative 16i becomes positive 16, and those 20s cancel. So on the bottom we have 25 plus 16, which is 41. And on top we have 15 minus 28, which is negative 13, and 12 plus 35i, which would be 47i. So I should look at all three pieces here to see if they have something in common. 41 is prime, 13 is prime, so there's nothing in common there to ever divide out. So that is it for that problem. Again, the point there being to get the I out of the denominator was accomplished. Oops. Alright, the last one here. Again, I want to get the I out of the denominator, so I'm going to multiply by the conjugate. So 3 plus 6i. Same thing on the top. little easier on the top this time. 4 times 3 is 12. 4 times 6i is 24i. All over. So we get 3 times 3, which is 9. 3 times 6i, which is 18i. Negative 6i times 3, which is negative 18i. Again, there's that sign switch helping us out. And negative 6 times 12 6 is negative 36. Then I squared. Up on the top, we just have 12 plus 24i still. Nothing there changes. And on the bottom, those cancel, and this becomes a positive 36. And so 9 plus 36 is 45. And the last thing I want to do is look for common numbers I could divide out. And all of those numbers have a 3 in them. Which means that 12 divided by 3 is 4. 24 divided by 3 is 8i. And 45 divided by 3 is 15. And then now they are all as small as I can make them. Well done. Again, the point was to get the I out of the denominator. We were able to accomplish that. So I'll use the quadratic formula. So let's remember what that is real quick. Bx equals negative b plus or minus square root b squared minus 4ac all over 2a. So I'm making sure that we have 0 first. A is 4, B is negative 7, and C is 1. So it's x equals negative times negative 7 plus or minus square root negative 7 squared is 4 times 4 times negative 1 all over 2 times 4. So that means that x is equal to a positive 7. Negative 7 squared is 49, not negative 49. So what I notice here is I have 2 negatives. That makes this is going to be a plus. And 4 times 4 times 1 is 16. All over 8 equals 7 plus or minus the square root. 49 plus 16 is 65. Over 8. I should check to see what's going on 65. 65 is just 5 times 13. So there's no pairs there to break out or anything, so that means I cannot reduce this. So it's done there. 7 plus or minus the square root of 65 divided by 8. Alright, next one. So A equals 1, B equals negative 16, and C equals 64. So X equals negative B, so negative 16 plus or minus negative 16 squared minus 4, which is times 1 times 64 all over 2 times 1. So it gives me positive 16 plus or minus square root. 16 squared is 256. So what I notice here is there's only one minus sign, so it's still minus. And 4 times 1 times 64 is 256. All over 2 times 1, which is 2. So, of course, it gives me 16 plus or minus the square root of 0 over 2. Well, square 0 is 0, plus or minus 0 is just 16. So x equals 8. Which we should have known there was only going to be one answer. As soon as we found out that this was 0, because there's our discriminant, and the discriminant is 0, then that means there's only one real answer to that problem. So, matches what we learned there. Write the function in standard form. Standard form being ax squared plus bx plus c. So basically we just want to simplify this. So I'm going to do some FOIL. That'd be m squared and then positive 6m and negative 6m, negative 36. So these guys here will cancel, so that just leaves me with m squared minus 36. So f of m equals that. Put it back in the function notation. Similar thing here, since the I-square though, and just remember it's not okay to just do this. What that means instead is that we should be, think about what it means to square something, which means multiply it by itself. So 2x plus 3 times 2x plus 3. And then go through the FOIL, which would be 4x squared plus 6x plus 6x plus 9, which will give me 4x squared, and then 6 and 6 give me 12, and 9, so f of x equals that. So there it is in standard form. And let's see what else we got here. Alright, so use the graph below to find the following. F of 2. So normally inside the parentheses we have the x value, so that means they're telling me that x is 2. So if they're giving me x, that means they want to know what y is. So I go where x is 2, draw a vertical line until I hit the graph, and then I go horizontal from there. Looks like y was at negative 1. So f of 2 equals negative 1. F of negative 3, pretty similar idea. Go to where f is negative, or x is negative 3. Which is over here. Draw up till I hit the graph. Horizontal from there. Looks like 4. So f of negative 3 is 4. Find x such that f of x equals negative 1. So here we don't know what x is, but they're telling us what y is. So kind of we just do backwards. So at negative 1 we go both directions horizontally. So it looks like there's 2 values for x. X would equal negative 2 and x would equal 2. State the domain. So the domain is your x values. X goes from left to right. So basically what I want to think about is what's happening on the left side of the graph, then what's happening on the right side of the graph. So look at the left side of the graph. So again, not really looking here, but the leftist most point of the graph, actually, not the coordinate plane. So that arrow is going off to the left forever. As I try to move to the right, as I follow the graph, as I keep moving right, well, it's going to keep going right forever also. That means the domain is from negative infinity to positive infinity. Or you could say all real numbers. The range is your y values, which means we want to look at the bottom of the graph to the top of the graph. What's the lowest point we see? What's the highest point we see? So let's look at starting at the bottom part of the graph. So as I move up, trying to find where the lowest part of the graph is. We see it's right here. It's at negative 5. I get some brackets since we're actually hitting negative 5. As you move up, try to see where the highest point of the graph is. Well, the graph's going to go up forever. So it'll be from negative 5 to infinity. Or you could say that y is greater than or equal to negative 5. Last question here is the graph discrete or continuous? So discrete graphs are made of points, or we have discrete points. So generally where the data would not be connected by lines. And continuous graphs are connected. So each point is connected to other points. So since we don't see individual points here, we see a continuous line. So Alright, so there is page 5 of the review. Done.